This video is on exponential growth. We are going to do some real-world example. Infections seldom start with a single bacteria. Suppose that you cut yourself on a rusty nail that puts 25 bacteria cells into the wound. Suppose also that those bacteria divide in two every quarter of an hour. Complete the table showing the first several numbers in the bacteria growth pattern. So number of quarter-hour periods, so starting at 0, number of bacteria in the cut, we have 25 bacteria in the cut at the very beginning. A quarter of an hour later, which is 15 minutes, this value, the cells divide by 2, so that means that we're going to have, instead of 25, we're going to have 50 now, because each cell divided in half, so then we have 2 more of them for every one. So we originally started with 25, now we have 50. At the next quarter hour, which will be another 15 minutes, these 50 will then split in half, so we'll have another 50 more. So then we'll end up having 100 bacteria in the cut. Then the next time, these 100 bacteria will cut in half, and so they'll get another 100 in there, so we'll end up with 200 bacteria. At the next quarter hour, we'll end up with 400 bacteria. The next quarter hour, we'll end up with 800 bacteria, and then the next quarter hour, we'll end up with 1,600 bacteria. So what is really happening? When it says dividing in two every quarter of an hour, that means that the bacteria, one little bacteria, is splitting in half, so now we have 2 bacterias. If we have 2 bacterias, each of them are splitting in half, now we have 4 bacterias. So it's actually multiplying each time. We get more and more bacteria each time. So in order to get from 25 to 50, 50 to 100, we are multiplying by 2. The next value that we would want to get, we would have to just multiply 1,600 by 2. So now next rule would be the next value is equal to what we have now, so that's 1,600, but we would multiply that by 2. But we originally started at 25 bacteria. So to write a rule showing how to calculate the number of bacteria in the cut after X quarter hour, and that's what we're dealing with, quarter hour periods, we would write out, so we want to use N and X. So N is the bacteria, N depends, that's our next value. So it would be our next N equals, we started at 25 bacteria, and we're multiplying by 2 each time, but we're raising it to our quarter hour periods, which is raised to the exponent of X. X is the number of quarter hour periods. We have to be very careful on that. So question D says, how many bacteria will be in the cut after 3 hours? There's a difference here. This does not say 3 quarter hours. 3 hours, we have to break up into quarter hour periods. Well, there's 4 quarters in 1 hour, so that would mean that there are going to be 12 quarter hours, because X is in quarter hours. So when we do this, we would not use the number 3 in our equation, we would use the number 12 in our equation. So we would use the explicit form instead of the now next, because we don't need the 7th one, we need 12 quarter hours. We would use the equation N equals 25 times 2 raised to the 12th power. And using our calculator, we would get 102,400 bacteria after 12 quarter hours, or after 3 hours of time. It's not the 3 for 200, so we have to use 3 hours, which is 12 quarter hours. So how many bacteria will be in the cut after 5.5 hours? So again, 5.5 hours, we need to break into quarter hours. 5.5 hours is going to be 22 quarter hours. Now how do we find that? 5 times 4 is 20. That's where we got the 20 of it. But we already have another half of an hour, which is 2 more quarter hours. That's where we get the 22. You can also do 5.5 times 4, which gives you 22 quarter hours. So again, we want to use the equation here, the exponential equation, because we don't want just the next one, we want the 22nd quarter hour. So we would use the n equals, because we need to know their bacteria. We started with 25 bacteria, and we know we're multiplying by 2 each time, but it's going to be raised to the 22nd power. This will give us 104,857,600 bacteria. In 5.5 hours, we're going to have this over 104 million bacteria in the cut. Question F says, when will the cut have 25,600 bacteria? We want to graph this in Desmos or solve it out. So we have bacteria of 25,600. We would write the equation with our exponential equation. 25,600 is equal to 25 times 2 raised to the x power. So we would actually use Desmos or a calculator for this. We would graph y equals 25,600, and we would graph the y equals 25 times 2 raised to the exponent of x. And then we would see where they would intersect. They would intersect at 10 quarter hours, so at 10. We would say at 10 quarter hours, there is 25,600 bacteria. Because we ended up getting x is equal to 10. When we looked at the coordinate of where they crossed, the x value is 10. That's 10 quarter hours, not 10 hours. So if we did 10 quarter hours, that would be, 4 quarters give us 1 hour, 2 hours to get to 8 quarter hours. And then we'd have another 2 quarter hours. That'd be at 2.5 hours. So the last one says, when will the cut have more than 50,000 bacteria? So we would do the same thing. We would want to use Desmos. So we would want to have the 50,000 is equal to 25 times 2 raised to the x. We would have y is equal to 50,000, and y is equal to 25 times 2 raised to the x. We would want to find where they cross. They actually cross at a specific value. There are 51,200 bacteria, and I'm looking at specific quarter value. So if I'm looking at a calculator, it doesn't give me as accurate as Desmos at 11 quarter hours. But at 10, I have 25,600. So I know that between 10 and 11 quarter hours, I'll be able to have more than 50,000. So we can say between 10 and 11 is when it will reach 50,000 bacteria. So we know that at 11, that it will be at 51,200 because we can just multiply by 2 from the 25,600. So we can say that when x is greater than or equal to 11 quarter hours, we will have more than 50,000. Because at 11, we know it already is above 50,000. Using Desmos, we can get the exact value of when it will be. And we would say it's greater than that value. wherever it crosses would be the exact value of when it is at 50,000. So we would want the value that is greater than that x value. This problem was done using a calculator and just looking at the table of values, and we could continue this table of values. I could have just kept multiplying by 2 until I got up to 50,000, and I would have seen that at 11 quarter hours, we would have had 51,200, which is more than 50,000. Just increasing this table, we could have seen what happens with the numbers.